Okay, so we now turn to the problem with altered angles. And what I refer here, what I call an altered angle, is inside the trig function. So every problem we've done so far has been a trig function of theta. Now we've had some other stuff done to our equations. All right, we've had numbers times the trig function, added or subtracted to it. Right? We even had a trig function squared. But in all of our examples so far, right, in all of our examples so far, it's always just been an angle theta. So when we talk here now about altered angles, we're talking about the circumstance where this angle is something other than just the single variable. Something other than just the single variable. Okay, so for example, maybe we have the equation here. Um, let's say sine of 2 theta equals minus 1. Okay. So here's how we approach this problem. So first things first, the original problem is always looking for theta in the interval from 0 to 2 pi. Okay. Another way of writing that problem, theta is in 0 to 2 pi, is to say that theta is inside this inequality here, 0 to 2 pi. Okay. But now we're solving a problem not for theta initially. We will eventually solve for theta. But initially we're solving for the angle here, which is 2 theta. So theta has to be between 0 and 2 pi. Well, if you change that to a 2 theta, you'd have to multiply it by 2. So you'd have to multiply those constraints by 2. And so we're initially going to be looking for answers between 0 and 4 pi. Actually, because of it being the double angle 2 on the theta, we're actually doubling the range of values we're looking at. We're going all the way to, we're going all the way up to 4 pi, 2 turns around the circle. So that's the first observation we have to make. And then what I do once I've made that observation is I come over here and I change my problem back to something I'm used to already talking about, where I have a single thing as the angle. Just with the understanding now that I have this new range of possibilities for it. So we change our problem to sine u equals -1. Now normally the first thing we would now do is find a reference angle, except for one thing. -1 is a quadrant value for sine and cosine, so that idea is not going to work. Since that's a quadrant, I would come over here and say, okay, where's that going to be at? Sine is -1 down here, right? The y value is -1 down here at 3 pi over 2. Right, so what I would do, since there's only the 1, is I would write that answer down. Now that's if I was going one time around the circle, but now because of the doubled angle, and since u is representing that doubled angle, we have to keep going. So we have to find, and as we go the second time around the circle, what would this be? Well, that would be the thing that is coterminal to 3 pi over 2. In other words, it would just simply be 3 pi over 2 plus 2 pi, right? 1.5 plus 2, which would be 3.5, or 7 pi over 2. 7 pi over 2. So those would be my two answers to this equation as I range between 0 and 4 pi, 2 turns around the circle. If we go around the circle anymore, we're going to be past that 4 pi. So, and of course we can't go backwards or we'd be below 0. So those are my two angles. And then once I've solved it, gotten however many angles I have, this time I have 2, sometimes you might have more, as I go back now and solve for theta. So 2 theta equals 3 pi over 2 and 7 pi over 2. All right, we have to solve that equation for theta. So that means I need to get rid of that 2 right there. Since it's in front, I could divide, but because I'm dealing with fractions, it's probably easier to think of it as multiplying by the reciprocal. Multiplying by 1/2. And so when I do that, I get theta equals 3 pi over 4, right? 1/2 times 3/2, and 1/2 times 7/2 will be 7 pi over 4. So I end up getting the two solutions. So definitely a little bit more involved when we're dealing with this process here. Right? Definitely a more involved process as we're solving these equations here. But the key idea again is we first expand our range. We first expand our range. Right? First expand our range. And then find all the solutions in that expanded range. And then we go back and solve for theta. Go back and solve for theta. So it's not a lot different. There is just that extra bit that we're going to have to be solving for more angles initially, as then we then solve for theta or x or whatever the variable might be.